So today I want to talk about a fairly interesting comparison. On one side, we have square root of 2 plus square root of 3, and we're comparing this with cube root of 31 for which expression is greater overall. On the left-hand side, we have a sum of square root terms with smaller integers on the inside, and on the right-hand side, we have a single cube root term with a far larger integer on the inside. This is a comparison between radical terms with different indices, since we have square root terms on one side and a cube root term on the other side, which makes the comparison a little more interesting. So let's just get rid of the cube root first, and we can do this by cubing both sides of the expression. Since both expressions we started with were positive, all we're doing is multiplying by positive values on both sides. So we don't need to change the order of the inequality. So when we cube both sides, it's still the same comparison. To do this, we need to use the formula for a plus b all cubed and use this for the specific case where both terms are square roots. We can infer a formula for square root of a plus square root of b all cubed using the a plus b all cubed formula, and I'll just use that to cube square root of 2 plus square root of 3. So square root of 2 plus square root of 3 all cubed is equal to 2 square root of 2 plus 3 times 2 square root of 3 plus 3 times 3 square root of 2 plus 3 square root of 3, and if we cube the cube root of 31, that's just equal to 31. If we combine like terms, the left-hand side simplifies to 11 square root of 2 plus 9 square root of 3, and the right-hand side is still 31. After cubing both sides, it's still the same comparison. That is to say, if square root of 2 plus square root of 3 all cubed is greater than the cube root of 31 all cubed, then square root of 2 plus square root of 3 is greater than the cube root of 31, and vice versa. We should now square both sides to reduce the number of square root terms on the left-hand side, and we can use the a plus b all squared formula to find that 11 square root of 2 plus 9 square root of 3 all squared is equal to 485 plus 198 square root of 6. And on the right-hand side, 31 squared is equal to 961. If we subtract 485 on both sides, we are now comparing 198 square root of 6 with 476, and we can divide both sides to get 99 square root of 6 on the left-hand side and 238 on the right-hand side. If we square both sides again, we end up with 9,801 times 6 on the left-hand side and 56,644 on the right-hand side. This is the same as comparing 58,806 with 56,644, which means the left-hand side expression is the greater of the two expressions. We can use this to infer that the original expression on the left-hand side is the greater of the two expressions because we have only done the same operations that don't change the order of the inequality on both sides at each step. This implies square root of 2 plus square root of 3 is greater than the cube root of 31.